On this session we will talk about rationalizing denominator, and this probably would be the last one about how to work with surds. And rationalizing denominator will be very frequently used in your questions in further work. So what is that actually? When you calculate something and when you have fraction and in denominator you have an irrational number, that is surd, then your answer should be given in rational numbers. So you have to get rid from that surd in denominator. We already learned how to do it. But now we will go through some questions to actually to make a little bit better confidence in this area, as is it really important to know exactly how to rationalize denominator. So we will start of course with first question, and it's very simple. 9 on root 6. So we have in our denominator one irrational number, or surd if you like, and as I said, we can't leave our answer. Suppose if we calculate something, if we were solving some question and after calculation we came to that result, then of course we can't leave that result as a final answer. So we have to get rid of this square root here, actually of this surd. We said we can do that if we multiply, but not only denominator, be careful, not only denominator, because you can't multiply just denominator. In that case you will change the value of the whole fraction. That would be something like, let's say if you have 3 on 4 for example, and suppose now if you, or I have to take a better example just to tell you what's happening here. Let's say one improper fraction, 4 on 2. Of course 4 on 2 is equal to 2. So the value of that fraction is 2. Now if you multiply only denominator, in that case you will have 4 over 4, which is 1. So you change this to some other value, and that definitely can't work. But if you multiply 4 on 2 by 2 on 2, you didn't change value of 4 of 2, because this is still is 2. Because you have 4 times 2 is 8, and 2 times 2 is 4, and 8 divided by 4 is equal to 2. So we didn't change this value, still is the same value. That is exactly what we should think when we are rationalizing denominator. So we can't multiply this fraction by square root 6, just by square root 6 to multiply denominator. We have to multiply basically this fraction by 1, but number 1 we will write like square root 6 on square root 6, of course that is 1. And now what we have 9 root 6, but here root 6 multiply root 6 is just 6. So the value of this fraction and this fraction here is exactly the same. We didn't change the value of our fraction, but what we change this denominator. In originally that was surd, but now we don't have surd in denominator anymore, we have just a whole number, and that is a process of rationalizing a denominator. Don't worry about surd in numerator. Usually we don't need to rationalize numerator. We are always rationalizing denominator. The next one is root 3 to root 2. It is similar. The only difference in this denominator, we have one whole number that multiplies our surd. However, our target is to remove surd from denominator, and we don't care about this number here. So we will multiply that fraction by root 2 on root 2. And of course, we have root 2 multiply, I will write root 3 multiply root 2, and here 2 root 2 multiply root 2. Of course, we know that is root 6, and root 2 multiply root 2 is just 2. 2 multiply 2 is 4. Again, the value of this fraction is exactly the same what value of that fraction is, because we are multiplying that fraction by 1. So when you multiply by 1, value stays the same. But we don't have any more surd in our denominator. Here, for this question, you can do something different, but it's not necessary, and actually it's not good way to rationalize. Sometimes people doing this like that. So they are multiplying this by 2 root 2 on 2 root 2, which is correct anyway. Still, this is 1. You are not changing value of your fraction, but definitely you will get rid from square root in denominator. But later on you have to simplify, because it will be 2 root 6, and here will be 4 times 2 will be 8. Now, of course, you can simplify, you have to simplify actually, and you will get root 6 on 4, which is the same, but here we have one step more to do, and it is not necessary to do that step. So remember, when you have a number that multiplies your surd, then don't include that number in rationalizing, because this is the whole number, and really you're doing nothing in that case, just making some problems for no reason. Simply look your surd and organize your fraction here to multiply your original fraction to get rid of that surd. So question 3. One plus root 5 on root 7. I mean, nothing special in this question. Still, we have to multiply our fraction by root 7, on root 7. The only difference from previous questions that now we have to expand, I mean you have to multiply by root 7 both of those. So I will write here, this should be like root 7 multiply 1 plus root 5, and here of course root 7 multiplied by root 7. So in our denominator, root 7 multiplied root 7 is just 7, but here we have to expand brackets, and will be root 7 plus root 7 multiplied root 5 is root 35, and this will be answer, because we can't simplify this any further, we can't simplify anything here, so this we should leave as an answer. But question 4 says to rationalize denominator of 3 and 1 minus root 2. So when you compare those two questions, you may see that now in denominator we have two terms, if you like, two numbers, while here was just 1. Now we have to be careful. We can't get rid of square root 2 if we simply multiply this fraction root 2 on root 2, because what is happening here will be 3 root 2, but now we have to expand 1 minus root 2 by root 2. So root 2 multiply 1 is root 2, and minus, of course, root 2 multiplied by root 2 is just 2. So what did we do? Basically nothing. Basically nothing, because still in denominator we have a third, but we have to get rid of third. So remember, this doesn't work, this here doesn't work for that question. So we have to look for some other fraction to multiply this to get rid of third. If you remember from 2 or 3 sessions before, when we were talking about this, I told you that always here you have to change sign. So this you have to multiply by 1 plus root 2 on root 2, and then you will get rid of third in this denominator. On the top we have 3 times 1 is 3, plus 3 root 2, but here 1 multiply 1 is 1, 1 multiply root 2 is root 2, minus root 2 multiply 1 is minus root 2, and minus root 2 multiply root 2 is just 2, and plus root 2 and minus root 2 is 0, and in denominator 1 minus 2 is minus 1, on top 3 plus 3 root 2. Of course, this you can't leave like here, because in denominator you have minus 1, so that is minus, and you may open the bracket and write 3 plus root 3 root 2, or even better, minus 3 and 1 plus root 2. So, what did we do here? simply we came to some conclusion that this denominator should be multiplied by like itself, but with one opposite sign. Once again, I will come back to formula for difference of two perfect squares. So what we had here, this is something like a minus b multiply a plus b, and we know that is a squared minus b squared. Then if our a is 1, because on that place, and our b is root 2, then simply for a denominator we have those two when we multiply, but using this formula will be 1, we said that is a power 2 minus b is root 2 power 2. And of course now when we calculate this, that is 1 minus 2 equal minus 1. So that is that minus 1 here. Once again, I am not forcing to memorize like this formula and to work with this formula, but I am telling you actually how we know that we should change a sign here when we multiply that. We know that because we see that product as this product here, but if we know that that product is giving us this here, so definitely then it can't be surd in our denominator, because both of them are to the power 2, and any surd to the power 2 is just a number, it's not a surd anymore. So when we connect those things, then that is how we know that here we have to change sign. So that was question 4. Question 5. We have almost the same question, because most of my questions are somehow similar, but with just one difference that you can understand concept just looking on that difference. So the difference between question 4 and question 5 is just in this sign. Here we had minus, here we had plus. But what we discussed when we were solving question 4, now we have to multiply by 1 minus root 2, 1 minus root 2. Again, see here, we multiply wait. This was something what is wrong. I told you not to do like this. I will just write now correct way. So multiply 1 plus root 2 on 1 plus root 2. So see here minus, we had pluses, now we have plus, we have minuses always. We are changing that sign here, and will be 3 multiply 1 minus root 2. And if you wanna go with formula, one that I told you, that will be 1 squared minus, I will write here, 1 squared minus root 2 squared, which is 1 minus 2, which is minus 1. But also you can expand 1 times 1 is 1, 1 times root 2 minus root 2, root 2 multiply 1 is root 2, and root 2 multiply minus root 2 is minus 2. And see what we have here. Now after cancelling those two, we have 1 minus 2, which is minus 1, and we said that we can write that minus in front, and here 1 minus root 2 to be our answer. I will see if sometimes there is no question like what I am going to tell you now. Don't get confused. Sometimes you may have a situation like this, for example, 3 but minus 1 plus, let's say, root 2. Don't get confused. I mean, that would be exactly the same if you have minus a plus b. So you can write this b minus a, why not? And also this here you can write root 2 minus 1, and now when you are rationalizing denominator, here will be root 2 plus 1, of course root 2 plus 1, whatever is here, 3. So don't allow to confuse you that minus here. Simply swap them around, and again you will get minus in front. Or also may happen a question like minus 1 minus root 2 to rationalize. I mean, this is just like playing some games by this minus, but you have minus here, you can take minus 1 as a common factor, and then you have minus 3, and here is going to be both pluses, 1 plus root 2, and now who cares, simply change this sign, and you are perfectly fine to continue. Of course, you can't forget about this minus, so minus and whatever later on you have, you are keeping that minus. So those few like examples I actually connected with this here to tell you how to avoid problems in case if you have minus somewhere else, not in between those two numbers. Probably we may have similar questions later, but anyway, better to get that understanding now. So question 6. Question 6. We have 1 plus root 5 root 3 minus root 2. So the difference between this question and questions 4 and 5, now we have both of those numbers are surds, and we have to rationalize denominator, we have to get rid of those two surds. I can't see any problem here. We should follow the same concept what we learned in previous few questions. So to multiply this by root 3 plus root 2 and root 3 plus root 2. Only sign minus here, plus is here, and everything is perfectly fine. Of course, now we have to multiply this. I will put this in brackets. At the moment, 1 plus root 5 multiply root 3 plus root 2. And here, if you wanna expand, you can. That will be root 3 multiply root 3 is just 3. Root 3 multiply root 2 is root 6. Minus root 2 multiply root 3 is minus root 6. And minus root 2 multiply root 2 is minus 2. And of course, this we can cancel, and we have 3 minus 2, that is 1. I will write 3 minus 2. Basically, this here you are getting if you make square root 3 to the power 2 minus square root 2 to the power 2, which is 3 minus 2, that is 1. So you can go on this way, but also if this still may confuse you, then simply expand, simplify, and you will get your answer. I mean, we can expand this to the top, but we can't get much from that because nothing to simplify. Anyway, that will be square root 3 plus square root 2 plus square root 5 multiply root 3 square root 15 and plus 5 multiply 2 square root 10. This is even worse result because expanded form, and remember always keep your answer in factorized form, and that is simpler form than expanded form. So anyway, just to write the complete result, that is because denominator is 1, and you should leave answer in factorized form, and it will be perfectly fine for full marks. I'm looking if anything else about this question to tell you. Basically, that's all. Simply change sign and whatever, this way or that way, you will get rid of your denominator. That is question 6. Question 7. Root 2 plus 3 root 5 root 2 minus 3 root 5. It's very similar question like previous one. The only difference, now we have one whole number that multiplies root 5. Here you have to be careful because at the beginning, I think first or second question, we had something like 3 to root 2, and we said this should be multiplied by root 2 on root 2, not to involve the whole number. Be careful here, you can't multiply this by root 2 plus root 5 on root 2 plus root 5. This can't make denominator rational number. Still, in this case, you will have in denominator square root. So this way couldn't work. Simply because I have a look, I will just expand denominators. Root 2 multiply root 2 is 2, root 2 multiply root 5 is root 10, now minus 3 root 5 multiply root 2 is minus 3 root 10, and root 5 multiply root 5 is 5, multiply 3 is 15. Okay, here we have number, but what to do with this? This will give us minus 2 root 10, so we couldn't get rid from square root from our denominator. That's why, to do it correctly, you have to include this number here. So this we should multiply by root 2, 3 root plus 3 root 5 and 3 root 5 here, and now will be everything correct. Now will be everything correct. Of course, we will do the complete question. So we have root 2 plus 3 root 5 multiply root 2 plus 3 root 5, and here root 2 multiply root 2 is just 2, root 2 multiply 3 root 5 is 3 root 10, minus 3 root 5 multiply root 2 will be minus 3 root 10, and minus minus 3 root 5 multiply 3 root 5 will be 3 times 3 9, 5 times 5 is 9 times 5 is 45, and of course you have plus 3 root 10 minus 3 root 10, you can cancel, and your denominator will be 2 minus 45, and your denominator will be minus 43. So there is no square root in your denominator. Actually, there is no surd in your denominator. Of course, numerator you can expand, but again you see this multiply that, this is the same thing, so like this to be to the power 2, or anyway I will do it. Root 2 multiply root 2 is just 2, root 2 multiply 3 root 5 is plus 3 root 10, then root 3 root 5 multiply root 2 is plus 3 root 10, and 3 times 3 9 times 5 is 45. And can I write it here? I will write it better here. So we have 2 plus 45 is 47, plus 3 6 root 10, and here minus 43. So that would be answer. Of course, we can't take anything common, we can't simplify anything. The only don't keep that minus here. Instead, that minus better to write in the level with fractional line, and then that would be our final answer. So once again, remember, when you have two surds, and if you have numbers including in front of surd, then you have to include that number here when you rationalize a denominator. Otherwise, you can't get rid from a square root. Question